Wow, is that a wombat?
It sure is.
What even is a wombat?
A wombat is a stocky-legged quadrupedal marsupial native to the southeastern coastal regions of Australia, including eastern North South Wales, eastern and southern Victoria, southeastern South Australia, and the whole of Tasmania.
Wow, how did they evolve into the species they are today?
Well, I'm glad you asked. Let's dive in, shall we? Wombats, like all the larger living marsupials, are part of the Diprotodontia. The ancestors of modern wombats evolved somewhere between 26 to 55 million years ago. The earliest fossil records of wombats are from the early Miocene about 20 million years ago. About 9 species, placed in 6 genera, are known from the Pleistocene. Some of these were very large, such as the Phasclodus gigas, which had a skull 0.4 meters in length, an estimated weight of 200 kilograms, and a height of approximately 1 meter tall.
Wait, but how do these species differ from the wombat today?
Ancestral wombats are distinguished from their present marsupial grazers by their possession of a single pair of incisors in the upper jaw and teeth with open roots. Found in fossil deposits from 23 MA, the earliest known of the wombat line was the Rhizophascolonus from the late Oligocene. From the later Miocene, all later species have open-rooted teeth. Warrinja, the smallest species, was the least specialized and occurred from the late Miocene to the Pleistocene. As a result of its teeth and burrowing adaptations, this animal resembled a very large rabbit.
So, what is the closest living relative to wombats and what is their common ancestor?
Koalas are most closely related to wombats, having shared a common ancestor, the Diprotodon, in the Oligocene or earlier. Both are members of the suborder Wombatiformis and order Diprotodontia.
What mechanisms of microevolution could have caused these changes in allele frequencies and populations?
Well, some marsupial species are known to have pretty large sinuses. Even extinct animals, such as the Diprotodon, the largest marsupial ever discovered, had massive sinuses that extended all the way through the skull and over the brain towards the back. Since this discovery, scientists have wanted to know what the relationship between body size, brain size, and sinus size was in the Wombatiformis. For example, as they got bigger through evolution, did their brains decrease in size while their sinuses increased? In other words, a better sense of smell, but less brain power to figure out what it is they were smelling. What scientists found was that in the larger extinct Wombatiformis, the sinuses seemed to almost surround the inner brain, but in the smaller living species, the sinuses were much smaller. Because of this, the size of the brain negatively scales with increasing cranial size, meaning that the larger-headed species have bigger sinuses but smaller brains in general. The reasons for larger marsupials, including these Wombatiformis, having smaller brains can be due to any number of reasons surrounding microevolution. Some of these reasons might be 1. The brain is an expensive machine to run metabolically, or 2. Environmental conditions related to the seasonality. It might be then that smaller brains are necessary in order to compensate for higher energy demands due to having a large body, something known as the expensive brain hypothesis.
What was the earlier environment of wombats? Does it differ from the one they have now?
Bombatus ursinus from the moist forests of southeastern Australia reaches a size of up to 40 kilograms. It is restricted to altitudes above 600 meters at the northern limit of its range. In the southern parts of its range, it ranges from sea level to the tree line in alpine regions. In the past, it had occupied areas throughout southeastern Australia, extending to the Murray River in South Australia and Queensland in the north, as well as Tasmania and several Bass Strait Islands. Hackett's wombat, Bombatus hackettii, was present in Western Australia until about 40,000 years ago, indicating that a common ancestor probably extended all across the southern parts of the continent. Both species are believed to have been restricted to the more southerly regions as the climate warmed over the last 12,000 years, the western species having gone extinct when its habitat changed too much or too fast for it to adapt to the new conditions. The living species may have moved to higher altitudes at the northern limits of its range as a response to the same climatic changes.
Have there been any reproductive isolating mechanisms that may have eventually caused wombats to diverge and become different species?
Though we don't know for sure, there very well may have been. These reproductive isolation mechanisms could have included anything from pre-mating isolation mechanisms such as temporal isolation or ecological isolation, or through post-mating isolation mechanisms such as zygotic mortality or hybrid inviability. I doubt that gametic incompatibility or behavioral isolation would have taken part in the wombat's reproductive isolation, as the morphology of ancestral wombats and current wombats, as well as their behaviors, are fairly similar. In terms of coevolution, almost all animals co-evolve with their parasites, and wombats are no exception. Currently, there is a disease afflicting the wombat population called sarcoptic mange. Sarcoptic mange is caused by a mite called Sarcoptes scabi, which burrows into the skin of the wombat. The wombat's immune system has yet to adapt to the mite in order to fight it off. Last but not least, when it comes to artificial selection, there is no records of wombats having been subjected to it. And that's it for wombats. I hope you enjoyed.